All right, polynomials, and what are they? It's a sum or a difference of terms where the variables have whole number exponents. So all you have to do is look at the exponents, the variables, and their exponents, and if those exponents are whole numbers, it's a polynomial. Remember, the whole numbers are 0, 1, 2, 3, nice, solid, whole numbers. No fractions, no negatives, no decimals. So the first one we have right here, this is not a polynomial. Can you tell why? Exactly. This right here is not a whole number. How about the next one? Is that a polynomial? Yes, that's a polynomial. Because we have a 3 and a 1, both of which are whole numbers. How about the next one? For that variable we have a 1, so that is now a poly. How about the last one? Polynomial, not a polynomial. Exactly. Right here is what makes it not a polynomial. So if the exponents are all whole numbers, nice clean exponents, polynomial. If they're not, then they're not. That's it. Alright. Let's look at this. Now we have classification. So if it is a polynomial, we can call it a monomial, binomial, trinomial, or polynomial. So monomials look like this. There's only one term. No pluses, no minuses. Okay? No addition, no subtraction. Binomial. It would look like this. Or like this. You have one plus or minus. We have basically two terms. And for monomial, it's one term. Trinomial, you guessed it, three terms. So it will look like this. Or like this. We'll put a cube on there just so we don't think, oh, it's always going to be an x. And that's a trinomial. That's it. And if it has more than three terms, we just call them polynomials. Okay? So the next thing is degree of the polynomial. And this is not the actual definition. This is just a generic one. But you can look at the largest exponent. It'll get us through most of what we need. There is a better definition if you want to look on that. Look it up. Go ahead. But we're not going to be using it. So, largest exponent. So if you look at this, this is not a polynomial. Let's just cross it off. Next one. That is a polynomial. What is its largest exponent? Degree is 3. Exactly. This is a polynomial. And its largest exponent is 1. So it has a degree of 1. And then the last one is not a polynomial. So it does not have a degree. Alright, so now you can identify these polynomials. You have its classification as a monomial, binomial, trinomial. And then you have its degree. Remember, it has to have whole number exponents. So you look at the polynomial. If it has whole number exponents on all the variables, it's a polynomial, and you can call it a monomial, binomial, trinomial, or polynomial of degree something. So if we look at the first one, there are 1, 2, 3 terms. So we can call it a trinomial. Degree 2. How about the next one? Yes, that is a polynomial. Degree 3, because that's the largest. And then the last one is a binomial. Degree 1. And this one is not a polynomial. So you can just stop. Alright, we have some more vocabulary. We have descending order, leading term, leading coefficient, and constant, which means there's no variable. So descending order is just a nice way to write polynomials. And what you want to do is always put the largest exponent first. So the variable with the largest exponent, that goes first. And then you just put it in descending. So minus 3x cubed, move the sign and the number of that variable you have. And then plus 4x squared plus 2x and minus 1. So all you're doing is shuffling. You're putting this one in the front, putting this one next, and then that one goes after that, and then that one at the very end. And this allows us to say leading term. So we have 1, 2, 3, 4, 5 terms. So our leading term is 5x7. Leading coefficient, the coefficient is the number right in front of your variable, so we say 5. And then the constant, that's the one without a variable, right there, -1. And that is polynomials.